Students, I am taking here two question of the topic mathematical induction. The questions are, actually I will start from here. Use the principle of mathematical induction. We have to use the principle of mathematical induction in these steps. In these, actually these are called the mathematical statement. We have to use, and by using principle of mathematical induction we will prove this is, of course, this is a correct mathematical statement. Okay, so I will start from the question number 6. I am taking two questions. This is the question number 6 of your book, and it's 16. Okay, you can check from the book. So see the solution, see the proof, actually see the proof here. So we will start from here. At first we will suppose this statement. We are supposing as I will suppose here, as per your book, let Tn, that is equal, I will start from here, that Tn, actually I need a space, Tn such that it's a 1 into 2, not a 1.2, plus 2 into 3 plus 3 into 4, okay, plus n of n plus 1 is equal n into n plus 1 into n plus 2 upon 3. Okay, so now students, what is your basic step? From the basic step, you know very well, you will put 1 at the place of n. Okay, so basic step, you should write here the basic steps here for n is equal 1. Okay, here this part is known as of course this is your LHS here, and this n is equal 1. What does it mean? This is the matter. For the LHS part, you are seeing that it's a series. That means it doesn't mean that you will put n is equal 1 at this place. No, it's not a mean. It means also the first term. And as per the your AP and GP, n is what? Number of terms. Okay, so number of term, I'm talking the first term. So first term is 1 into 2. Okay, so this means 1 into 2 is equal, if you are talking about the RHS, here the value of n is 1 directly. Here is not a series. We have not a series in this RHS, so we will put 1 at the place of n. Okay, this is your LHS portion. This is called the LHS portion, and of course it is RHS. If LHS and RHS both are same, that means this statement means T1, you can say the T1 here is correct. Okay, so 1 into 2 is equal 1 into 1 plus 1 into 1 plus 2 upon 3. Okay, so this 1 into 2 means 2 is equal 1 into 2 into 3 upon 3. 3 cancel out. Finally what we have, a 2 is equal 2. Or you can say, this implies, you can say LHS is equal, this is LHS, RHS. So you can write here, hence T1 is true. Okay, now we will write the induction step. What is the induction step? See the induction step. For induction step, we will suppose that this statement, this Tn is true. This statement, whatever we have supposed, it's a Tn is true. Okay, so assume that Tn is true, where your n are what? These are natural number. Capital N is a natural number. So now if this is true, as we are assuming that it is true, of course it is true. Okay, so we will now prove that of course T of n plus 1 is also true. If you can write here the statement, if Tn is true, so at first I will write here Tn is what? Tn is this is Tn 1 into 2 plus 2 into 3 plus 3 into 4 it's n of n plus 1 is equal n of n plus 1 n plus 2 upon 3. This statement is, of course, this is true. Okay, so we will prove that induction statement means you have to repeat again only. Okay, so we will, but you will assume here that Tn should be true. So we will prove that if Tn is true, so T of n plus 1 is also true. So now students, we will work on T of n plus 1. Okay, so see here, so T of the statement, how it's very important, T of n plus 1, such that here students see T of n plus 1 means at first we will write that T of n terms. Okay, so T of n is what? It's a 1 into 2 plus 2 into 3 plus 3 into 4 plus it's n of n plus 1. It's, of course, this is your Tn term. Okay, Tn is what you have supposed here, the Tn. Okay, but we have to indicate here the T of n plus 1. So students, you know very well, I will explain at this place. I am talking about the what is the nth term. Nth term means an. Suppose that I am taking here the n. Okay, so if I am talking to you, what is the a of k term? Okay, so you will write here the k. If I am talking about a of k plus 1, so if your an term is small n, I am talking about what is the a of k, you are writing here the k. So if I am asking to you what is the a of k plus 1 term, so this is what? It will be k plus 1. Just like I am asking to you what is the T of n plus 1, this will what? This will be, here we will put what here, see here at this place, if here is n and if I am talking about a of k plus 1, so you are putting just k plus 1 at the place of n. Similarly, I am talking about the T of n plus 1, so this means we will write n plus 1 at the place of n. So this is what? N plus 1 plus n plus 1 and plus 1. Okay, actually we are putting here n plus 1. Okay, so this is the LHS part. And now what is your RHS? Now from the RHS you are seeing it's n of n plus 1 n plus 2 upon 3. Is it clear? So we will put n plus 1 at the place of n. So this will n plus 1, break it, here we are putting what? N plus 1. Okay, this is also n plus 1 plus 1. Okay, n plus 1 plus 1, break it close, and the next one is what? N plus 2. This means it will n plus 1, n plus 1, yes, of course, n plus 1, I need a space, n plus 1 plus 2, okay, upon 3. If you want to simplify, you can simplify it. N plus 1, this is what? N plus 2, and it is what? N plus 3 upon 3. This is your RHS. Now I am going to take your LHS part. If LHS is equal RHS, this means it is true. Okay, so see here. Okay, yes, actually you have to see also it. So now we have a T of n plus 1 such that, I will repeat this statement again, 1.2 plus it's not a 1.2, it's 1 into 2, actually 2 into 3 plus 3 into 4 plus up to n of n plus 1 and plus n plus 1 and n plus 2. Okay, this is your LHS. So students, actually I have to write completely here. It's n plus 1. I will write this thing same step I have to repeat it. N plus 2, n plus 3 due to copy. You don't need. So students, we are going to take the LHS. This part is your LHS. So LHS, if you are taking the LHS here, what is your LHS? It's a 1 into 2 plus 2 into 3 plus 3 into 4 plus n into, actually, n plus 1 plus n plus 1 into n plus 2. Students, I want to ask you, what is the value, what is the, this actually it's a up to dot 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 here, it's a plus 3 into 4 plus dot 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 of n into n plus 1. So we know very well this is the series, and what is the value of this series? The value of this series is what? N. See here, from the Tn you can find out, it is n of n plus 1, n plus 2, okay, upon 3, and this is what? Plus n plus 1 n plus 2. Is it clear? So students, we can take common, what we can take the common from here, n plus 1 and n plus 2. So what we have a here we have only n, and here we have a n upon 3, this is, and this is 1. So finally what we have a n plus 1, n plus 2, and this is n plus 3 upon 3. Now this is, you can prove here, you can see from here, actually this is your RHS and this is also your RHS. This means T of k plus 1 is true. Of course, T of n plus 1 is true, actually. This is equal RHS. Okay, so you should write here what we have proved. So here we have to mention this term. So we here T of k plus T of n plus 1 is also true. Since, why it is proved? Because since T of n, this implies T of n plus 1 is true. You should write after the proving this part. Therefore, by the principle of, and you have proved this thing by this principle, this is called the principle of mathematical induction. So therefore by the principle of mathematical induction, T of n is true, okay, for all n belongs to n. Okay students, you can see the complete solution from here in this way. This is the complete solution at first this page. If you want to take the screenshot, you can take the screenshot this place. In this way you can take, right now you can take the screenshot. Okay, next page. This is your first page, and now ready for the next page. Yeah, this is the next page. This statement you have to mention after the proving of T of n plus 1. So students, I am on the next part. This part has been over. Now I am on the 16th part. Okay students, now I am on the question number 16. Okay, so see directly the proof. I have already explained the question number 16 to you, and now ready for the proof. Here we have a Tn, and what is your Tn? Tn such that 1 upon 4 into 7 plus 1 upon 7 into 10 plus 1 upon 10 into 13, it's plus 1 upon 3n plus 1 and 3n plus 4, where that is equal n upon 4 into 3n plus 4 in this way. Okay, all of you are watching? Yes. So students, what is your basic step? I will not repeat again and again. It's a basic step for n is equal 1. Okay, so t of 1 is what? The second, what is the n is equal 1 means your first term, up to first term there is 1 upon, such that your LHS it's a 4 into 7. This means here we will put n is 1 into 4 into 3 into 1 plus 4. So this is, of course, this is 1 upon 28, and thus it is also equal 4 into 7, it's 28. Okay, so then our T1 is 2. Okay, ready for the induction step? Your induction step is, let Tn is 2. So what is the value of the Tn? Tn such that it's 1 upon 4 into 7 plus 1 upon 7 into 10 plus 1 upon 10 into 13. Okay, up to 1 upon the last term of the series is 3n plus 1 and 3n plus 4. That is equal n upon, it's very easy. The main issue is about the n plus 2, t of n plus 1 series. Okay, so 4 of 3n plus 4, no issue. I have just write down this thing. Now here we will write here Tn is true, this Tn is true only when is true, only when t of n plus 1 is true. Okay, so now we aware, so t of n plus 1 such that here how I have told to you, here we will mention 1 upon 4 into 7 plus 1 upon 7 into 10. Okay, I don't want to mention this part. Okay, up to 1 upon, actually I need space, plus 1 upon 3n plus 1. There is no issue with this term, 3n plus 4, but the matter is now started. So here we know very well, if I have already told to you, if your a n term is last term is, suppose that n, I am taking a of k term is k, so a of k plus 1 is what? This is also k plus 1. Okay, so similarly this is your, you can say this is your series, your Tn. Okay, now what is Tn plus 1? What is the n of n plus 1 term? Okay, so this means you will put only what you will put, n plus 1 at the place of this n after applying plus. Okay, and this will be your LHS part actually. So 1 upon, it is 3 into n plus 1, is it clear? And now plus 1 bracket close, and now ready for the next part, plus 3 into n plus 1 n plus 4, bracket close, and that will equal the RHS. Here in the RHS you will put n plus 1 at the place of n. Okay, actually this is not a series, so n plus 1 upon 4 into 3 of n plus 1 plus 4. Sorry, here I want to simplify this RHS. This is your RHS. Okay, I want to simplify it. Actually, what is this? So it's n plus 1 upon 4 into, now if you multiply this 3 with the n plus 1, you will get a 3n plus 3 n plus 4. So this becomes n plus 1 upon 4 into 3 n plus what? Plus 7. this is your RHS. So we will start from the LHS. We had to prove here. Okay, so students, see the LHS. See the LHS. Your LHS is, you know very well, this is your LHS. This complete part is your LHS. This complete part you can see from here to here. This complete is your LHS. But I am talking about this portion. This is your Tn. This is what Tn, and the value of this Tn is given. This is what the value of Tn is, n upon 4 into 3n plus 4. So LHS is what? Here I am going to write directly the value of this Tn. Tn is n upon 4 into 3n plus 4. Any issue? And now we will apply the plus sign. Actually the value of this series is given. Okay, so plus 1 upon, now students see very carefully, it's a simplified, it's a 3n plus 3 plus 1. This means this becomes 3n plus 4. 3n plus 4. And now next is, it's a 3n plus 3 plus 4. This is what? 3n plus 7. Okay students, this is the different part. Okay, ignore it. We had to prove, actually we have simplified only the RHS. Okay, before this we have not simplified, but I have to simplify it here. So now students, we need to take this LHS. Okay, so now student, 3n plus 4 is common, so we will write the 3n plus 4 here. And now we have a what? We have a n upon 4 plus 1 upon, it's a 3n plus 7. Is it clear? Now take the LCM. Here the LCM is 4 into, this thing is going on properly, 1 upon 3n plus 4. So 4 into 3n plus 7. So now student, what? 4 cancel out. We have a 3 n into 3n plus 7 and plus there is 4. Is it clear? Now see here. Now students, it's your work. I will give it to you. It's a 1 upon 3n plus 4, and this is 3n square plus 7n and plus 4. Okay, and students, if you solve this portion, I will tell you here, if you solve this portion, you will get this RHS. This RHS means this RHS. If you solve it, okay, means what will be cancelled out? 3n plus 4 will be cancelled out if you solve it. I will tell you directly here the factors. If you solve this quadratic equation, you will get what? You will get the factors. I will simplify. Actually I don't have a space now, but I will tell you here. This is n plus 1. This is the factor n plus 1, and 3n plus 4 upon, it's a 3n plus 4, and here is 4 into 3n plus 7. So you can see 3n plus 4, 3n plus 4 cancel out, and finally we have the RHS, hence proved. Okay, and mention the main statement. What is the statement? Therefore the truth of Tk implies that the truth of Tk plus 1 means T of k plus 1. If this thing is true, T of n plus 1 is true. Okay, so Tn is also true. Is it clear? We use here the T of n plus 1 is true, then Tn is also true. This is the statement for the mathematical. You have proved it by the help of mathematical induction. Thanks for watching. Okay, and now you can start the next exercise. I will also tell you the next question on my Zoom app. Okay.